Hello, we are here to talk through this Kakuro non-consecutive variation by Thomas Snyder. It's themed on 2022, and you can see all these 20 and 22 sums around the grid. These will actually play into the solve as well. We'll see how it goes. So at the top right here, I can start with a simple pattern, which is true for regular Kakuro as well. The only way to resolve this 6 and 14 intersection is in this way. Now, looking at the bottom symmetric pair like this same pattern over here, this could be a 2 and 3 in a regular Kakuro, but it can't be in this variant. So this would be a 1 and 4 pair. Now, this is a 4, then this is a 3. That's not possible as well. So you get a 1, a 6, and a 4. Now, I'll draw your attention to these 22 sums. So usually you would have 5, 8, and 9, and 6, 7, and 9. So in these combos, there are always consecutive digits. So in this variation, you need a separator for these consecutive digits, and that will always be in the middle cell. So in a 5, 8, and 9, to separate the 8 and 9, you need a 5. In a 6, 7, and 9, to separate the 6 and 7, you need a 9. So that's true for all 22 sums. So I'll just go ahead and put it in all of them. So because of that, this is a 5-9 pair, and now we get an 8 over here. That forces the 5 and forces the 9. It also forces the 6, 7 here and here. Now, in this 22, the remaining digits are 1, 2, 3, 4, and 7 because 6, 8, and 9 have to be missing. So in this cell, 1 and 2 are too small to appear because the 20 sum would not get satisfied. If it's a 3 as well, you would have 8 and 9 here. So actually 3 would never be possible here because 8 and 9 are consecutive. So the only remaining possibilities are 4 and 7. Now, if it's a 4, this clearly can't be a 5 because you need a 9 and 7. If it's a 7, again, this can't be a 5 because you'd need an 8 in between. This is broken because of this 8, but also because it's consecutive to the 7. So either way, what that proves is this has to be a 9. And that gives us a 6, 7 here and here as well, which leads into this sum, this 27 sum. These two cells sum to 13. And also this 22 sum can't be a 6, 7, 9 anymore. So it's an 8 or a 9. So within these 4 cells, which have to be summing to 14, if we have a 9, then the remaining 3 cells would have to sum to 5. That's too low. So you need an 8 over here, which forces a 5 and a 9. And also forces a 6 because 7 can't be next to the 8. And these are all forced. Now, the remaining 3 cells here have to sum to 6. So that's 1, 2, and 3. And the 2 has to be separated from the 1 and 3. So the 2 actually goes up top. And we have a 1, 3 pair here. And let's just mark the 4, 7 here as well to resolve the 20. Now, in this 22 sum, since this is a 6, the remaining sum is 7. So you have to have a 4 to separate the 1 and 2, which resolves this. 3 can't be next to 4. So that resolves the 1, 2 pair here as well. For this 22 now, 3 and 7 are the only digits remaining. 3 can't be next to the 4. So 3 and 7 this way. Now let's look at this 7 sum similar to these remaining cells. The 4 has to separate the 1 and 2. Also, this 22 sum. Now, if this is a 5, then this would be an 8 or a 9, which is both of them are too big for this 17. So this actually has to have a 9, and that means the remaining 2 cells have to have a 6 and 7. Now, this 22 over here cannot have a 6 because 22 across 6 cells has to have 6, 8, and 9 missing. So 7 and 6. That means these 4 cells now sum to 11. So that would be 1, 2, 3, and 5. So the 5 would have to be in one of these 2 cells. It can't be next to the 6. Also in this 22, you need a 5 somewhere. It can't be next to the 6. So it would have to be in these 3 cells. Also, you need a 4 somewhere. So this row cannot have a 4 at all because it's a 41 and you subtract from 45 and it's 8 cells. So you can't have a 4 anywhere. So the 4 would have to be here for the 22. Now this cell cannot be either of the 4 or the 5 because it would lead to it being consecutive to the other one. So 4 and 5 are gone from here and you get a pair over here. That also means that you can't have a 3 over here now because it'll be next to the 4 either way. So you get a 3 down here and a 1 2 pair up here. Now this cell over here, it's part of a 22 sum, and we know that that's missing 6 8 and 9, and we know that 1 and 2 are too small for this cell, so it could be a 3. It can't be a 4 or a 5 because it's next to this cell, and either way they'll be consecutive. So the other possibility is 7. So now, because this is a 3 or 7, this is a 4 or 8, and now we can look at this uh, sum, which we said was 4 cells and 11. So the 5 always has to act as a separator to separate the 2 from the 1 and the 3. So what ends up happening is either the 5 and the 2 are placed in this way, or the 5 and the 2 are placed in this way. Because if there's a 5 here, let's just visualize it. You can't have a 2 here or here because it would be next to the 1 or the 3. So either 5 and 2 or 5 and 2. Now this possibility, if this is 5 and 2, then this can't be a 4 because it's next to the 5. This can't be a 3 because it's next to the 2. That makes this 8 and 7, which is too big for the 20. So the 5 2 pair actually has to finish in the above area, and that forces these markings as well. So this is 1 and 3, that's all that's left. Now in this area, because this is a 4 or 5, again what we can do is the 4 and 5, the other 4 or 5 would have to be in these two cells. Also, there can never be a 2 in this because it's too small for the 20. So the 2 would also have to come in these two cells, and 4 cannot be here. So you have a 2 4 5 triplet over here. That means that this cell has to be a 1 3 or 7. Now we know that 1 is too small for the 20 sum. 3 is also too small in this non-consecutive variant because this would lead to 8 and 9 over here. So this is a 7 that lets us get these digits. And also now the 4 can't be next to the 3. So this is the 5, this is the 4, and this is the 2. So the only remaining digit here has to be a 5, which forces an 8 here. Now let's look at this 8 sum because it's interesting again, like the 22. In the sense it could be a 1 2 and 5 or a 1 3 and 4. If it's a 1 2 and 5, then the 5 would have to be in between, and if it's a 1 3 and 4, the 1 would have to be in between. Now we see this 40 sum, which is 8 cells, and you need to subtract from 45, which means 5 is missing. So that means this can only be a 1, and also we get a 3 4 pair here. Similarly, in this 14, we can use the same thing. Since 5 is missing from here and this can't be a 9, this would actually become a 6 and 8 pair. Now, this 13 sum, the 2, so you can't have a 2 here and you can't have a 2 next to the 3. So you can't have a 2 in the sum at all. So that actually means that it now minimizes. It has to be 1 3 4 5. Now the remaining digits are 1 4 and 5. 4 and 5 cannot both come here, or another way to look at it is the 4 can't be next to the 3 and the 5 can't be next to the 4. Sorry. And that means the last digit is a 1 over here. Now this 17 sum has 8 already in it. So the remaining two cells have to sum to 9. So that can be done. It can't be done by 1 and 8. It can't be done by 7 and 2. And it can't be done by 4 and 5 because that would force a 5 over here next to the 4. So it's a 3 and 6, and the 3 has to avoid the 4. That also resolves this, and it also resolves this. Now, this 6 and 3 sum to 9. That means these two cells sum to 13. It can't be a 6 and 7. It could be a 4 and 9, but the 4 would be next to the 3. So it's actually a 5 and an 8, and the 5 has to avoid the 6. Now this is a 12. That means the remaining is 10. Actually, this is probably easier to do because only 3 and 7 are left. We know that 5 is missing. So 7 has to avoid the 8, and 3 comes here. And that also means that now this is 15. So you get a 7 here as well. Now we come to this bottom area, which is all that's left. This 2 and 4 means that this is either 6 and 8 or it's 5 and 9, and 5 can't be next to the 6. This 11 means that this is 9, the remaining two cells sum to 9. It could be a 6 and a 3, but both 3 and 6 are here, so that's not possible. Can't be a 4 and 5, can't be a 7 and 2, so it has to be a 1 and 8. So now let's look at this cell over here. This could be a 1 or a 2 or a 5 or 7. If it's a 1, then this is a 7, which is too high because you would need, so you would need 1, 2, 3 here. We already proved that can't happen. So because the 2 would never separate from the 1 or the 3. So this could never be a 7. If it's a 6, then you would reach a pattern like we saw over here. So a 4 would come here, and this would be a 1 or 2, which is too low for the 20. So again, you can't have a 6 here as well. So this can't be a 1 or 2, this has to be a 5 or 7, and this is a 1 or 3. Now, whether this is 8 or 9, you can't have an 8 over here. So this is a 1 and this is an 8. So now in this area, since 4 is missing, you still need a 2. The 2 can't be next to the 1, so the 2 is here or here. So this cell could be either 5, 7, 8, or 9. I'm trying to remember here. Sorry about the delay. So this can't be a 9, this can't be a 7. Can it be a 4? If it's a 4, then this would be a 7, and we already know that would cause 1, 2, that would cause a 1, 2, 3 triplet here, which is not possible in this variant. So it actually can't be a 4, it can't be a 3 because that would force 8 and 9. It can't be a 7, 8, or 9. So this is actually a 5 or a 6. If it's a 5, then you can't have a 7 or 8 here because that would be consecutive to each other. So this would be a 9 and a 6. If it's a 6, then the only possibility is a 5 and a 9. So either way, the 9 acts as a separator and you get a 5, 6 pair over here. So that forces this also to be an 8. And these cells now will be a 2, 5, 7 triplet. So this cell now, if it's a 5, then the remaining cells sum to 8, and you can't have 1, 2, and 5 in those 8. So it has to be 1, 3, and 4. And in a 1, 3, and 4, the 1 acts as a separator, and the 3 and 4 are on either side. So what that would force is a 1 and a 4 over here. But the 4 would be next to the 5 in that scenario, and those would be two consecutive digits. So that whole scenario is not possible. So this is actually a 6 and a 5 and 6. So now these three cells sum to 7. So that's a 4. This would be a 1 or 2 since 2 is already eliminated. This is a 1 and a 2. So 2 and 7 and 5. And this is 11 for these three cells. So the last cell would be a 9. So this Kakuro was heavily driven by 22 sums. First, the 3-cell 22 sums with the separator in the middle, and then the 6-cell 22 sums because 6, 8, and 9 are missing. As we progressed, we also used the fact that 5 isn't present in this and 4 isn't present in this. That was useful as well. So all of these clues were put in a very in a way that they were all very useful. So we hope that this walkthrough was helpful for you. Thanks, Thomas, for the puzzle, and thank you for watching.